Most corporate manufacturing relies on a framework called analogical reasoning. You evaluate your production metrics, look at what your competitors are doing, and attempt to replicate their processes with minor optimizations. Because this approach anchors your baseline to the existing industry standard, your operational ceiling is capped. Success is defined by shaving off fractions of a penny or achieving a 10% gain in efficiency over the next quarter. Escaping that 10% ceiling requires abandoning industry benchmarks entirely. Instead of asking how other companies manufacture a product, you evaluate the production problem against the strict, absolute laws of physics. This operational philosophy translates into a rigid, 5-step protocol, known internally as the algorithm. It is a sequential, mandatory set of rules applied to hardware engineering. It is also the exact mechanical engine responsible for scaling both SpaceX and Tesla to industry dominance at a speed that traditional aerospace and automotive competitors considered physically impossible. Applying the unyielding logic of pure physics to manufacturing generates extreme output velocity. But human organizations are not made of carbon fiber and steel, and running them through a strict physics equation inevitably causes massive systemic friction. Before engaging the 5 steps of the algorithm, a company has to identify exactly where its manufacturing pipeline is wasting capital. To do this, engineers calculate what is known as the idiot index. This formula calculates the index by taking the market cost of a finished product and dividing it by the cost of its fundamental raw materials. In 2002, the aerospace industry standard for a single Russian rocket was $18 million. By calculating the spot market price of aerospace-grade aluminum, carbon fiber, and titanium, SpaceX realized the finished product cost 50 times more than its raw materials. A high index rating proves that the price tag is not dictated by technological limits. Instead, the cost is severely inflated by a cognitive premium, layers of supplier markups, bureaucratic inertia, and historical assumptions. This exact inefficiency paralyzed the early electric vehicle market. Automakers accepted the industry standard price for energy storage batteries, which sat at $600 per kilowatt-hour. This diagram illustrates the physical breakdown of those battery cells into their atomic components: lithium, nickel, cobalt, aluminum, and electrolyte. Buying those raw materials directly on the spot market cost just $80 per kilowatt-hour. The $520 difference between the physical cost and the market price is the cognitive premium. Erasing that premium required Tesla to abandon standard supply chains entirely, absorbing the manufacturing process in-house to build the components from the atomic level up. This directly inverted the macroeconomic trend of the early 2000s. Between 2000 and 2010, the United States lost 1/3 of its manufacturing jobs as cost-cutting executives offshored their assembly lines to third-party suppliers. Outsourcing saves on hourly labor, but it prevents order-of-magnitude cost reduction. Breaking hardware down to its raw material cost requires daily iteration, which is only possible when you control the machine that builds the machine. This schematic shows the actual execution pipeline of the algorithm, beginning with step 1, question every requirement. To prevent engineers from hiding behind vague corporate policies, every single requirement or specification must be explicitly attached to the name of the person who created it. You cannot challenge an entire department, but you can interrogate a specific individual's reasoning. Prior to a 2010 SpaceX launch, engineers discovered 2 microcracks on a second-stage engine skirt. Standard NASA procedure dictated scrubbing the launch for weeks to replace the entire engine assembly. By questioning the physics of the requirement, the team realized the engine had plenty of thrust margin to spare. They physically cut the cracked metal ring off with shears, bypassed the delay, and successfully launched the next day. This schematic advances to step 2, delete before optimizing. The operating rule here is strict. If you do not eventually have to add back 10% of the components or processes you removed, you are not deleting aggressively enough. Tesla engineers applied this by removing a noise-dampening vibration strip from the car bodies. Audio testing of the cabin interior proved the human ear could not detect a difference without the part installed, instantly eliminating an unnecessary manufacturing cost. Traditional management often falls into the trap of aggressively streamlining and improving a process. Step 2 asserts that spending capital and engineering hours optimizing a part that should not exist at all is a massive organizational failure. This diagram outlines the acceleration phase, encompassing steps 3 and 4, simplify and accelerate cycle times. Accelerating cycle time requires structural reorganization.